to the Where Humanity Meets Technology podcast, where we talk to business leaders about cybersecurity, data management, and advanced digital solutions to provide strategies to increase the profitability of your company. Now, here's your host, Maurice Hamilton, the CEO of Infinovate Consulting Services.
Hello, everyone. My name is Maurice Hamilton. I want to welcome everyone back to our podcast that we label Where Humanity Meets Technology. We like to interview different business leaders out there to find out how their organizations and their departments are actually utilizing technology for the betterment of human mankind. So we want to thank you for joining us today. Today, we have a really great guest here. I want to introduce everyone to Steve Orrin. He is an executive at Intel, the Intel Corporation. Steve, welcome to the podcast.
Thank you, Maurice. Happy to be here today.
Oh, we're so happy to have you. Thank you. I really appreciate it. So I'll get started here, and I have a question for you. The first question, which is what I like to call the Genesis question, and just to get a general background on you, Steve, how did you get involved with semiconductors? How did you get involved with Intel? Can you give us a little bit of insight about what you do over at Intel, and tell us a little bit about your history?
Sure thing. So it's an interesting story. Currently, I'm serving as the federal CTO for Intel Corporation, and in that capacity, I represent all of Intel's capabilities as applied to the federal market, federal government, and the broader public sector. And that's covering everything from AI to IoT, high-performance computing, and cybersecurity. My background is in cybersecurity, and if you go back to the beginning, back in the mid-90s, I did my first several startups back then, really looking at cybersecurity back in the nascent days of the internet when things were first starting to come together, trying to solve some of those key problems around securing desktops, securing enterprise and mainframe systems, and then later helped to start the web security marketplace at one of my startups. And in the mid-2000s, one of my companies was acquired by Intel. And at the time, I thought, okay, I'll help them acquire, get the technology up and running, and then move on to my next startup. And they came to me with a unique value proposition. They were looking at this area what they called pathfinding. So in Intel, classically, R&D is sort of the 5 to 10 year horizon, looking out in the future of semiconductor innovation, and the next chips take usually about a 5-year cadence from whiteboard to silicon. And then the product teams are building products at a 2-year cadence. And so every 2 years, a new product comes out the door. And what they had identified at that time is there was this in-between state of the 2 to 5 year horizon where innovation could happen sometimes in software or firmware on existing or hardware that was about to come out, but not what was already in the product as far as the capabilities and use cases. And so they were creating a pathfinding team and division, and they asked me to lead the cybersecurity pathfinding activity. And so for about 9 years, I ran security pathfinding, which is looking at how could we leverage the hardware that either we have or was about to come out to do something interesting in the cybersecurity space. And so got the opportunity to do hardware enhanced malware detection, leveraging hardware features to be able to detect things under the OS before your typical security tools come into play. Helped create the trusted cloud architecture of how do you use hardware to secure your cloud and virtualization environments. And so some very innovative approaches to leveraging what you had already coming in the hardware and creating your innovations in software and in firmware to be able to provide that value to the end customer. And then about 10 years ago, Intel made the decision to really focus on the federal market, not just from a sales perspective, but from an innovation perspective and from a direct engagement perspective. And so they were standing up a federal focused team, and they asked me to lead the federal technology practice here at Intel. And so I moved back east to the DC area to stand up a team of solution architects and subject matter experts and capabilities around addressing the government requirements. And really, a lot of the role is, both translating Intel capabilities into government speak so that the senior leaders and technology directors can understand what the technology can do for them or how they can apply it to their enterprise and mission needs. And then the flip side, translating government requirements back into Intel speak so we can build our products to better meet the government requirements both today and in the future. And along the way, being able to do some really interesting innovations of taking our hardware and I'd say taking commercial products and federalizing them for the federal market, helping to create those derivatives or those extra innovation requirements to be able to fit into the mission domain or if into the specific use cases that the government has. So it's an exciting opportunity that I've had for, and I've really loved for the past 10 years to take the breadth of what Intel provides to the world and apply it to the unique and sometimes challenging use cases that you find in the federal market.
Wow, that is excellent the way you laid that milestone out. Because when you first started the conversation, I thought about the 8088 processors, 286, 386, 486. Then we got to the Pentiums, and you were translating that about the 2-year gap because they said Moore's law, every 2 years the technology seems to change, and it still seems like you're still looking at that 2-year. But you said there's also a transition before it actually gets to that 5-year mark, and you're looking at that. And you mentioned something else I'd like to see if I can expound on a little bit about cloud computing. So, I mean, cloud computing is taken to another level. Can you actually give us just a little bit more insight on how you guys are doing that with the cloud computing today?
Sure. So at its core, the cloud is running on Intel. So 85, depending on the market numbers of the day, anywhere from 85% to 90% of the cloud is running on Intel technologies. And it's more than just, there's a server in the cloud that ultimately those cloud stacks are running on. It's how do you get the most out of the cloud? And so a lot of the innovation, both at the silicon level and at the firmware and software level, is about optimizing the code to run at scale with the security, with the performance necessary to operate at those hyperscaler, as well as the data center private cloud environments. A lot of the core technology in the hardware, virtualization and isolation and optimization, memories I/O, networking traffic I/O, and optimizations are the underpinnings that allow for the cloud to do what the cloud does. So the fact that you can deploy your workload and scale it to the infinite cloud, get access to your data resources, connect to sensors at the edge, a lot of the infrastructure underneath that is driven not just by the Intel hardware, but by the innovations and the connection points between that Intel hardware and the software that you interface with. And it's software up and down the stack. So it's the operating system or hypervisor from vendors, as well as the OSs and the applications are all taking advantage of acceleration and computing capabilities that are specific to the Intel architecture. That x86 provides those instructions and the interfaces to be able to do all those wonderful things around cloud orchestration, cloud scale, and really distributed computing that we see in the cloud today, as well as things like security and performance enhancements. So a lot of times, you want to be able to do encryption. Well, of course, you can do that in software, but when you scale that into a cloud, that becomes a huge performance bottleneck. By having instructions in the hardware that are exposed as APIs to the software, we can offload all that encryption onto hardware and give you the performance so that encryption doesn't get in the way of your cloud scale requirements. And so that's just one example of the many of features that we've built over the years to enable the cloud scale and and high performance computing at the levels that we see in the public cloud providers today.
Wow, that's fantastic. And when you mentioned the security, integrating that to connect with the software, that's amazing. So when you think about the evolving markets, you mentioned a little bit about AI. And 2 years ago, we saw ChatGPT came out and just completely took that market off to a different level. And but I know that Intel, you guys were actually heading that way anyway. When you think about that, so when you think about evolving markets, Steve, what do you think about with like AI, blockchain, and even let's even take it a little step further. What do you think about like with quantum computing? Where do you think that the evolving market is going right now?
So Maurice, let's unpack that question a little bit and look at it from a couple of perspectives. So AI, as we know, AI has been around for many, many years. And there are a couple of different inflection points that really, ChatGPT was taking advantage of. One is the computing power finally came to bear where it could handle the kind of complex mail in a performant way. And to be able to do those large scale processing without waiting weeks for a decision or an answer. The other is that we had the sufficient amount of data to drive that AI engine. So that, they say that data is the oil. It is absolutely the gas that is driving the AI revolution. And so having the easy access to data, the connectivity to get access to that data, the computing power to process it, and then the mechanisms to deliver on those answers is really that inflection point. Underneath the covers, though, when you look at the AI, whether it be a ChatGPT or even something like object recognition in your car, when you're doing autonomous driving, all of them at the heart start with being able to take the data, curate it, process it, do the training, do the optimization, and then deploy the algorithm out to be able to do the inference. There's a pipeline or a life cycle associated with AI. Everyone is sort of fascinated with the ChatGPT front end and with the training, the billions and trillions of parameters that go into that. And that's an important part of the story. It's important to also recognize that there's a whole long tail of work and computing processing that happens to get to that point. And so when you look at the overall life cycle of what's involved in developing these large language models, these generative AI approaches, whether they be at the ChatGPT or Llama kind of scale, or even at the more domain specific scale that you find in enterprises or in a lot of these IoT use cases, it's about being able to process the data throughout the end-to-end life cycle. Where Intel has been innovating is across that end-to-end cycle. So of course, on the cloud, in the data center, having instructions in the hardware that accelerate the training and the inferencing. And while everyone's focused on GPUs as the answer to all AI, and they are an important piece of the puzzle, most of the day-to-day activity after you've done the training is inferencing, and that all happens on commercial hardware, standard processors is where you're doing that inferencing. But then you think about, well, where did that data come from? How did I collect that data? Or where did the data get generated? That's out at the edge. And that could be on your phone, your laptop, on an edge sensor in a smart city, in a medical device. They're all developing or collecting that data, processing it locally, transferring it through the network to the cloud. At each step of that, there's computing processing that's happening. There's acceleration that goes into making that a viable end-to-end pipeline. And so Intel is looked at as one of the few companies that can look at the holistic pipeline from the client to the network to the cloud, and then back to the decision maker or to the IoT device that's ultimately going to make that decision or ask that question. And so when you look at having the right instructions, the right acceleration, the right performance characteristics at every stage is how we're going to be able to achieve a lot of the promise that we see from AI.
Wow, that's amazing. Go ahead.
Sure. And then talking, I think you mentioned the next thing, which was, where is it going to go from here? What are some of the big things? And, and everyone's, enamored with quantum. And let's say quantum is a fascinating field. There's a lot of activity. There's some, call exquisite machines that are being built at Google and MIT and so forth to build, like what's going to be the biggest qubit machine we can build in a lab. And those are wonderful research projects. And they're really showing the state of the art of where we're taking computing, and a lot of the infrastructure around to build that system requires innovations. I think we are still a little ways off before we're going to see a practical quantum computer that any organization can get easy access, and I don't foresee anytime soon you're having a quantum computer in your desk. However, what we are seeing, and one of the things where Intel is focused on, and we have a quantum chip, it's the Tangle Lake and a couple others to demonstrate. But it's really how we build it that's really fascinating. If you look at the exquisite machines that get all the news, that they're building a multi-qubit chip in a cryo contained environment, and it's a one-off. They built that one chip. When we built our chip and we announced it, we show it off. It's built in the existing fabs where we're building our Xeons and our client parts. One of the most fascinating pictures on one of our press releases where they showed the Intel quantum chip, and they had a bunch of pictures of the different processors. There's one picture on the bottom that was sort of hidden off the side, but I think it's the most powerful one. It was showing the system that was doing the testing of that chip. So it's the thing that verifies that the quantum chip works, runs it through its paces, plugged into the exact same infrastructure. So it's a rack of servers that are doing testing for our normal Xeon parts. And really, it's at the core of what Intel is looking to do is how do you scale quantum computing? How do you take this idea and actually make it pervasive, make it available to enterprises, build it at scale, be able to do it across your standard fab infrastructure? And so I think that was probably the most fascinating part is we're able to build quantum systems using much of the same infrastructure validation and tests that you would for your normal commercial, our Xeon parts. And so that I think is one of the cool innovations of how we'll get to that scale is being able to do this, in a cost-efficient, time-to-market kind of model, leveraging the kind of infrastructure that we already have for producing our scale chips that go into servers and clients. And I think when you look at any of these kind of innovations, we announced a few weeks ago the world's largest neuromorphic computer based on our Loihi architecture. When you look at things, whether it be blockchain or other, post-quantum, A lot of it at the end of the day to enable those really cool is about how do you implement the right hardware architecture to be able to address those very specific requirements in those use cases. Probably one of the biggest innovations that I've been very excited about is moving from what we call the monolithic approach. You need to have one big chip that does everything, to a heterogeneous architectural approach where you can pull cores and FPGA parts and even ARM parts and cobble them together sort of like a Lego bricks into a multi-chip package and be able to give yourself the best of all the different computing architectures in one compute platform. When you get to that kind of scale, and we've already released products into the market that have that built in and the packaging technology that enables that interconnect. Now you're leapfrogging the idea of, well, I just need a smaller chip, which we absolutely do with keeping up with Moore's law. But when we start looking at things like AI or blockchain or sensing and being able to put optimizations, customizations into that architecture, how powerful is it to have, let's say, a programmable logic unit right next to the core processing unit, to have a GPU right next to the core processing in the same package on that high-speed bus, be able to do those kind of applications and the variety of applications in a much more natural and efficient way.
Well, I mean, I get giddy when you say that, because I'm thinking about all the applications you can use it for. I mean, you talk about military, you talk about healthcare, education, and the first thought I had was rockets going way past Mars. I mean, you can have that kind of processing computing power is just like amazing. Wow.
Absolutely. And being able to have the ability to customize without having to build custom ASICs every time allows you to innovate quicker to be able to meet those variety of mission or enterprise and end user needs.
Wow, that's amazing. So, I was listening to you with all that information. I thought about kind of a shadow that's been there in the last few years. That's going to be supply chain. So when I think about supply chain, I think and I read these articles about some of these other Taiwanese or some of these other companies, semiconductor companies, where they don't, if they're having supply chain issues, they're not really saying a lot about it, but I'm sure they are. Everybody's probably having the same problem. How are you guys addressing like supply chain, or is that still like a little small nuisance today than like it was 2, 3, 4 years ago?
So supply chain is actually a big deal. And I think one of the things that COVID actually highlighted for everybody is how brittle and single sourced our supply chain, how unbalanced the global supply chain was. And that was, I think it's something a lot of us knew, but it wasn't really, top of mind until you suddenly couldn't get cars built. And so what it did highlight was the fact that too much of the semiconductor supply chain was dependent on Asian sources. And again, it's not the geopolitical, it's just physically somewhere in Asia. And that is a problem when it comes to time to market, efficiency, as well as availability, whether it be a pandemic, geopolitical tensions, or just the time it takes to get things from there to here, and as well as having access to more domestic or localized supply chain for the variety of markets. So one of the things that when Pat Gelsinger came on board to Intel is he made clear is his goal was to rebalance the supply chain so that we have an even balance between the East and the West, where there's access and availability across the board, not just for the state-of-the-art processors that go into laptops and servers, but for the variety of chips. That's why we stood up the Intel Foundry to give access to everybody to be able to come in and build their chips on our process nodes. It's why we've also invested over $100 billion committed in US manufacturing as well as work in Europe to really help rebalance the supply chain. So supply chain is absolutely a critical thing, and we've seen the implications of where supply chains break because of a variety of reasons. So having more access in more places gives us predictability and to be able to supply and meet the ever-growing need, and the hunger for computing that we're seeing everywhere. Because whether you talk about AI or IoT or any of those technologies, at its core, it's the computing power that I need in order to be able to process those applications and fulfill the vision of what they're doing. And to do that, I need the compute. I need it where I need it, when I need it. I don't want to wait 6 months to get a GPU from overseas. I want to be able to get it now. And to do that, we need to rebalance the supply chains. And that's really at the heart of Intel's sort of domestication of our factories in order to be able to give more access to the global market to have that balance.
Okay, that's awesome. So I want respect your time. I have a couple of just two more quick questions for you. One, and you mentioned about the security, and you talked about encryption, and I think about, we do, like our company, we do a lot with cybersecurity, we do assessments, all the things that go along with that, and there's a lot. And I was thinking about that, man. How do you actually go back? And I know this technology's, you probably can't say some of it, that's probably top secret or whatever it may be. But I'm thinking about, what if we could just build that inside that chip so it's encrypted that they can't even access, even if it got into your system, you can't access the data. So how is that progressing along with Intel with the encryption part? I think that just protecting even your own intellectual property, that's got to be huge. Got to be a monumental interest. What do you think?
So Maurice, it's actually a great point. It's something that Intel has actually been in the leading edge on, is driving the ability to use hardware to protect data, assuming that you're running in a potentially hazardous or compromised environment. So we help create the Confidential Computing Consortium. We've built technologies into our platform, secure enclaves and confidential computing. And what at that core is using the hardware to both control access as well as encrypt the memory. So you think about data security, there's sort of three stages to data security. There's data at rest, data in transit, and data at use. The problem is, for the past 40 years, we've had basically good answers, if not the most performant, but it's gotten better around data at rest, full disk encryption, file encryption. Data in transit, it's your VPN, your SSL, your TLS, your IPsec, point-to-point encryption. But the last mile, data in use, was sort of an unknown thing, an unsolved problem for the longest time. What Intel introduced, going back to 2016, was this idea of confidential computing, of being able to put your actual application as it's running in memory in a protected container, where the hardware itself, the silicon and the memory, are encrypted, and it's controlled by the silicon as far as what's able to access it. So that idea of confidential computing is really that next wave of innovation around protecting your data, no matter how insecure the environment it has to live in. So you think about the cloud. You don't know who's running next to you. You're relying on the cloud provider to provide all the security of the infrastructure. And ultimately, they have to do a lot of work to protect your workload and your tenant. Having confidential computing allows them to sort of get out of the control base and be able to provide you the ability to secure your data in their environment. Similarly, as you deploy assets to the edge, you think about all those smart cities sensors, they have to be protected when anybody can walk up to a light pole and mess with the computer. So how do you protect it from both physical access as well as co-tenancy? That's where confidential computing comes into play. And that is really a revolution over the last 5 years of how to protect data through all stages of its life cycle.
Wow, that's just phenomenal. That's amazing. The last question I have for you then, I know we talked, and we probably already touched base on a lot of it. We talked about AI, we talked about quantum computing in detail, we talked about security. Steve, when you take a look at this and say, I know it changes so much. Let's say the next three to 10 years, where do you see technology evolving over to? It could be, what does the Steve Orrin crystal ball say?
That's a really good question. And there's a lot of ways we could take this. I think, a couple of things. I'll pick on a couple. So one, in the area of AI, I mean, obviously we're seeing every month or two, there's some new revolution, there's a new buzzword. It was Gen AI, it was GPT and transformers and large language models. Now RAG is really hot, it's really cool. And I think we'll continue to see innovation there. But I think, if we project out 3 to 5 years, what we will start to see is where AI is actually start to make a real impact on businesses. And it's not going to be the really cool, sexy chat bots or really interesting object correlation and recognition. It's going to be applying AI to the core business processes, really helping to automate and make more efficient the ERP systems, logistics and supply chain, contract management, HR, the internal operations of both small, medium, and large businesses and governments, optimized and made more efficient, and really being able to do that at speed. So be able to get to data entry to decision much quicker, where AI has been applied to that internal. And it may not be the most sexy part of using AI, but it's actually where I think we'll see the largest value creation and value proposition, is where we can automate a lot of these sort of manual legacy bureaucratic processes that just have existed the same for so long. there's going to be an inflection point there of applying AI sort of on the inside. And I think that's where we'll start to see a real uptick in that. And technologies like RAG are really going to be a game changer in that space. That's retrieval augmented generation. The other area I think is as connectivity really, as the promise of 5G. We have been talking about 5G for years.
Mhm.
There's still a lag before we actually get that 5G infrastructure really deployed. No matter what the buzzwords and the marketing material of the various telcos say, we have a ways to go before we get true 5G all the way out to the edge, into the user's devices, and into those IoT devices. Once we have that pervasive connectivity married up with pervasive computing at the edge, I think we'll start to see a lot of the vision and a lot of the cool ideas that have been sort of in the lab really go scale on how do you leverage that type of computing, data processing, and augment, whether it be augmented reality or AI recognition for traffic flow analysis. All those kind of use cases get enabled once we get that infrastructure really realized and deployed out there. And so I think that will be a game changer. And what will help on the other side of the innovation is as those things come into play, they're going to be generating a lot of data. And so that's going to then drive back to how do I manage and process those AI use cases in a distributed environment, moving away from the monolithic, it's everything in this one big cloud, Bard, Lambda, ChatGPT, to much more domain-specific AIs, where they're doing the collection, training, inferencing, and decision all the way out at the edge.
Wow, so that's amazing. Steve, I want to thank you. I think that this is going to be one of my better podcasts when I think people are going to play this one 2 or 3 times, because if they really take a deep dive into it, not only will they learn a lot of information, but they can look at the opportunities and say, what are some of the things that I could do with my business or my structure so I can prepare for that, so I can take advantage of this new technology that's coming down the pipe. So I want to thank you for that. This has been very enlightening.
Well, thank you, Maurice. It was a pleasure, and I look forward to hearing it.
Well, there you have it, folks. Steve Orrin, the federal CTO for Intel Corporation. We're so happy to have him here with us today. And so if you like this podcast, please feel free to like it and send some notes to us. And Steve, if they want to reach out to you, is there any way they can reach out to you at all?
Best way to reach out to me is on LinkedIn. So I'm Soren on LinkedIn, and that's the best place to find me.
Excellent. Thank you. Thank you, everybody. And we'll catch you on the next one.
Thanks for listening. If you've enjoyed this episode and you'd like to help support the podcast, please share it with others, post about it on social media, or leave a rating and review. To catch all the latest from your host, connect with Maurice on LinkedIn at Maurice Hamilton. Thanks again, and we'll see you next time.
Tonight on